section 3.2, we're going to be talking about domain and range. So our domain can be seen as a group of numbers that when we put into the function machine, it pops out a range of numbers. So this is your x value, and this is your, pardon me, this is your function value. So when we take our number that's part of the domain and we plug it into our function, what it gives us is the range. So there's a number of ways that we can write this. One is a basic inequality, which might look like any of these. Another way to write it is called the interval notation. So that's kind of the range of values that your output could take, written more as an interval. And then here's, if you were to graph it on a number line, what that would look like. And then the last one is actually a description of that, that interval in words. So let's take a look at a few of these. Sorry about that. Yep. Take a look at a few of these. So the first one is saying that x is greater than a. So it's greater than a. It's not inclusive. So that's why we're going to keep the open parentheses. And then it's everything greater than. So we want to make sure that we end it with an arrow indicating that that goes on forever. So our interval for that would be starting at a and going to infinity. Or if you wanted to write that as the inequality, then you'd be saying that x is greater than a. So let's look at the next example. The next example is saying x is less than a. So now we're going to put the open parentheses going the opposite direction and an arrow going towards negative infinity. So again, you would write this, the interval would be negative infinity to a, and we'll make sure that we end it with the parentheses because it's not including a. And then our inequality value would say that x is less than a. And let's look at the last, another one. X is greater than or equal to a. So x greater than or equal to a, which means that our interval is going to be a. Oops, that's going to be inclusive. Our interval is going to be a to infinity. So if we write this on the number line, we're going to make sure that we use the square bracket and face it in the direction that you're going. And this goes to infinity. And let's do a couple of the trickier ones. So here, x is strictly between a and b. So my x is greater than or equal, greater than a and less than b. My interval then is going to be from a to b, and my number line, I'm going to include only numbers between a and b. And let's look at the last one. X is between a and b to include a and b. So in this case, we've got our x greater than or equal to a and less than or equal to b. Our interval is going to be inclusive. So it's going to be from a to b. And then my number line, I'm going to make sure I use square brackets for both of those and only include what's between them. So those are just examples of lots of different ways you can write these intervals and these restrictions. So this one is saying that x can be less than 2 or x can be greater than 2. Our function here, if you can see why, we don't want the denominator to equal 0. We don't want this. So that happens when x equals 2. Because when we get 2 minus 2 equals 0, we do not want that to happen. So we want all numbers except for 2. So in this case, we're putting an open circle. That means we're not including that number. And it's all of these values on both sides of that. So you can write this in your interval as we're going from -2 to 2. And we're taking the union of those values and 2 to infinity. Here's some more examples of some more complex ones where we're including things and not including things. So you can write with the open circles, But I really like it if you get used to just using parentheses and brackets, because then when you're writing it in your interval notation, you're not having to mentally calculate back and forth. So if you've got an open circle on the 5 in that first line, that's going to be your open parenthesis. And then you've got a solid dot on the 10, so that's going to be a square bracket. And then you've got your values in between. And then if you can see, that goes straight into your interval notation. So now you've got your open parenthesis on your 5 and a closed bracket on your 10. I like not having to go back and forth between the two, but sometimes you're going to find that it's nicer to put the solid dot and the open dot. So use your own discretion, but if you have a preference, then I would definitely go for the parentheses and the square brackets. This one is asking us to rewrite it in all 3 notations. So we've got our, sorry about that, we've got our inequality. So this is saying that x can go, we want x greater than 1, and that's going to be greater than or equal to 1, and then less than or equal to 3. Or we've got x greater than 5, and that's it. So x value is greater than 5, and we've got our arrow, so that goes to infinity. We don't need to write that on this particular one, but we'll show that on the next one. So in this case, our interval our interval is going to be inclusive, and it's going to be going from 1 to 3, also inclusive, and it's going to be the union of that and not including 5 to infinity. And remember, anytime you do infinity, you're always going to use the parentheses, because we can't actually ever reach infinity, so we can never actually include infinity, if that makes sense. So always keep that an open parenthesis. And let's try this one. Oh, and then let's go back to set builder notation for this one. We didn't quite talk about set builder notation on this slide, so let me go back to that really fast. Set builder notation, sometimes you can write out the whole set of included numbers. So, sorry, that's an awful curly bracket. I was never good at writing those. So here's your curly bracket. And let's say my set includes 1, 2, 3, and 4. So this is my set, and my set is saying that it's all x values such that x is greater than or equal to 1 and less than or equal to 4. So that's called set builder notation. So this tells you what can go inside this set. So let's take this example. So this example is saying that it's a set of all set of all h's, such that h is less than 10. So we're not including 10, but we're including everything else. So in this case, our set might look something like 9, 8, 7, ... It might look something like that. All right, so our set builder notation for this one is going to be a little bit more complex. So we've got 2 situations. We've got the set of x's such that x is less than or equal to 1, and greater than or equal to 1, less than or equal to 3, or x is greater than 5. And that's our set builder notation. So let's do this one as well. So here we've got our inequality notation, and it's saying that x is less than or equal to -2. And that covers this whole side. And then this one says that x is greater than or equal to -1 and less than 3. So we're not including 3, so we want to make sure that we're not saying that it's equal to. So we don't want it equal to 3, we want to make sure that it's less than 3. So now we just combine these and that becomes our inequality notation. So we've got x less than or equal to, or x greater than or equal to -1 and less than 3. There's our inequality notation. And then our set builder notation is going to look somewhat similar. Sorry about that. And then our interval notation. So our interval notation is -infinity to -2 inclusive. Sorry about that. And inclusive -1 to 3 not inclusive. So there's your interval notation. Your inequality notation, because we're only using inequalities in that one. Here's your set builder notation, and here is your interval notation.